So this is a feasibility study that we're looking at whether DTAGs, which are known as suction cup tags, that collect a lot of underwater sensory data from different dolphin species. We wanted to see if we could use it on Hector's dolphin. There's a lot of research priority questions that DOC and Fisheries NZ have identified that need to be answered.
DOC and Fisheries New Zealand are responsible for looking after these dolphins under the threat management plan for Hector's and Maui dolphins. So we're responsible for looking after and managing the populations and subpopulations of these nationally critical species. So we're always looking for new technologies to be able to examine the lives of these animals so that we can better understand the threats that they face, and that the management programs we put in place to protect them from those threats are cohesive, enduring and effective.
Plenty of work has been done on understanding how Hector's dolphins behave on the surface where we can see them, but we know little about how they behave underwater. So Fisheries New Zealand has funded a project to understand whether we can use suction cup DTAGs that will monitor their movements underwater.
By being able to deploy the tags directly onto the dolphins, we get immediate information from the dolphins themselves about how they're living their lives. We can tell from the tag that, the speed they're going, the direction they're going, what orientation they're on at any particular point in that dive. It also records the sounds they make and the sounds that they receive. It even allows us to capture really important environmental information. So this is a really great way, in that the tag is attached with 4 little suction cups. And so we can deploy it directly onto the animal and without it causing it any harm. The tag itself is programmed to pop off after 24 hours. The tag can pop off by itself. There's nothing we have to do or that the dolphin has to do to get rid of it. And we knew that within a minute they were back bow riding and continuing with the very same behaviour they were doing to begin with. So this has no real impact on the animals themselves.
So we're getting a really good perspective of how the animal uses its underwater space. We also can begin to combine that information to see how deep it is when it's feeding. And with those echolocation clicks, we can see at what point it would be hunting and foraging. So there's a lot we can do with just these few sensors, and there's some other sensors that we could look at putting on in the future if we wanted. So the information that we're collecting has the potential to be really important in understanding this species from a subpopulation level as well as a whole species level. So what we really want to take a look at is, do these subpopulations in different areas, more isolated habitats, different habitats, do slightly different things? And do we need to manage them slightly differently in those areas? So that's really the most important part of this tool. So this project is quite a big collaboration. We've brought together all the people with expertise that we knew of to make this a success in terms of really testing the utility of this sort of technology with Hector's dolphin. So we have the University of Auckland, Dr. Rochelle Constantine and her team, Dr. Mark Johnson from Denmark. We also have the Department of Conservation, who's kindly helped us out, providing us boats and personal staff.
With all this new information about how these guys are living their lives, it really challenges the whole way that we perceive them and how they use their environment. And so it really keeps us on our toes in terms of ensuring that the protection measures that we put in place really do work for them.